Hello, hello. My name is Vikas. I am from CSCAML Section D. I take the topic from in the data structures graph, deeply understanding graph-based Sybil detection techniques via empirical analysis on graph P. Introduction to Sybil attacks on the detection. Sybil attacks involve creating multiple fake identities to manipulate or disrupt online systems. Detecting Sybil nodes is critical for uh, maintaining trust and security in social networks and peer-to-peer systems. Graph-based methods leverage network structure to identify anomalies indicative of Sybil behaviors. And we can see the image of a deeply understanding graph-based Sybil detection techniques via empirical analysis on graph processing. And you can see the image. Motivation for empirical analysis and graph P. Traditional detection techniques often rely on assumptions that may not hold in real world scenarios. Empirical analysis helps evaluate the effectiveness of graph-based detection methods under diverse network conditions. The research aims to deepen understanding of how different graph properties influence detection performance or on graph P. This is the motivation for empirical analysis on graph P. Overview of a graph-based Sybil detection techniques. Techniques such as community detection, random walk-based methods, and machine learning approaches are commonly used. These methods exploit structural features like connectivity patterns, clustering coefficients, and the node similarities. The choice of technique depends on the network to- topology and the nature of Sybil attacks. And this the topic of the overview of a graph-based Sybil detection techniques. The techniques such as community detection, random walk-based methods, uh, and are commonly used. These methods exploit structural features like connectivity patterns, clustering coefficients, uh, coefficients, and node similarities. And this is the overview of a graph-based detection technique. Sybil detection techniques, techniques such as community detection, random walk-based methods, mission, and learning approaches are commonly used. These methods exploit structural features like a connectivity pattern. Techniques such as detection, random walk-based methods, and machine learning approaches are commonly used. These methods exploit structural features like and node similarities. The choice of technique depends on the network topology and the nature of a Sybil attacks. And these are the overview of graph-based Sybil detection techniques. I hope you understand this the slide. And there's the same image of the slide. Next slide is the concept of a graph P. The concept of a graph P. Graph P is a symmetric or a real-world network used as a test bed for evaluative detection algorithms. It incorporates properties like degree distribution, clustering, and a community structure relevant to practical networks. Analyzing a graph P allows researchers to systematically study the robustness of detection techniques. Graph P, I will read in 1 second to understand quickly. Graph P is a synthetic or a real world network. Uh, the graph is a synthetic or real world network. Real world network means we can use the network of many connections beside our home or in another country in another mandal or another district or other states used as a test bed for evaluating detection algorithms. It incorporates properties like a degree distribution, clustering, and community structure relevant to practical networks. Analyzing graph P allows researchers to systematically study the robustness detection techniques, and we can detect the technique who are using the technique. This next one is a methodology for empirical analysis. The study involves generating or selecting multiple graph instances with varying parameters for comprehensive testing. Detection algorithms are applied to these graphs to measure their accuracy, precision, and recall. Results are analyzed to understand the strengths, strengths and limitations of each technique across different graph configurations. The study involves generating or resulting multiple or comprehensive methodology for empirical analysis. The study involves generating or selecting multiple graph instances with varying comprehensive detection algorithms are applied to these graphs to measure their accuracy, precision, and recall. The results are analyzed to understand the strengths and limitations of each technique across different graph configurations. The methodology for empirical analysis. The study involves generating for selecting, and I'm reading the second time of the this slide to understand quickly. The study involves generating or selecting multiple graph instances. This we can select the multiple graphs with instances with varying parameters for comprehensive testing. And we can use the comprehensive testing. Detection algorithms are applied to these graphs. And detection algorithms are also applied to these graphs to measure their accuracy, precision, and recall. Results are analyzed to understand the strengths and limitations of each technique. There is a strength, and in this each technique, we can see the each strengths and limitations of each technique across different graphs configurations. Uh, Key findings of detection performance. Detection accuracy generally improves with increased structural differences between Sybil and benign nodes. Certain features such as community separation significantly impact the success rate of detection algorithms. Uh, the effective of techniques varies depending on the density and the clustering characteristics of a graph B. Uh, high clustering High clustering portions can obscure the boundary between civil and legitimate regions. Degree distributions influence detectability of civil nodes, especially in scale-free networks. And understanding these properties helps tailor detection strategies to specific network topologies. This is the impact of a structural properties. And next, challenges and limitations. Adversaries may adapt their strategies to avoid detection, complicating structural assumptions. Large-scale graphs pose computational challenges for some algorithms, affecting real-time applicability. Empirical results highlight the uh, need for hybrid approaches combining structural and behavior analysis. Practical implication and future directions. Insights from empirical analysis guide the development of more robust and scalable detection methods. Future work includes exploring dynamic graphs and incorporating temporal information for enhanced detection. Collaboration across disciplines can further improve understanding the mitigation of civil attacks. Deep empirical and the conclusion. Deep empirical analysis of a graph-based techniques provides valuable insights into their effectiveness and limitations. The study on Group P underscores the importance of network properties in designing detection algorithms. Continuing research is crucial for safeguarding online systems from evolving Sybil threats. The references include relevant academic papers, data sets, and tools used in the analysis. Your second bullet, your third bullet. Thank you.